Welcome to Intelligence Gateway.
Topic Objectives. Lecture 17.1. TAS. Describe different types of encryption and how they secure IT systems. Encryption is a crucial technique used to secure IT systems and protect sensitive data from unauthorized access or tampering. It involves converting plain, readable data plain text into unreadable and scrambled data ciphertext using various algorithms and keys. The data can only be deciphered back to its original form by authorized users who possess the correct decryption key. Let's explore different types of encryption and how they secure IT systems. 1. Symmetric encryption. In symmetric encryption, the same key is used for both encryption and decryption. It's fast and efficient but requires a secure way to distribute the secret key among authorized parties. The security of symmetric encryption lies in the confidentiality of the key. If an attacker gains access to the key, they can decrypt all the data encrypted with that key. Examples of symmetric encryption algorithms include Advanced Encryption Standard AES and Data Encryption Standard DED. 2. Asymmetric encryption. Public key encryption. Asymmetric encryption uses two distinct but mathematically related keys, a public key and a private key. The public key is widely distributed and used for encryption, while the private key is kept secret and used for decryption. Anything encrypted with the public key can only be decrypted using the corresponding private key, providing a higher level of security. Asymmetric encryption is slower than symmetric encryption, that provides additional features like digital signatures and key exchange. RSA reverse Shamir Edelman and DCC elliptic curve cryptography are common asymmetric encryption algorithms. 3. Hashing. Hashing is not encryption per se, but it is an important cryptographic technique used for data integrity verification. It takes an input message and produces a fixed-size string of characters. Hash value. The same input will always produce the same hash value, and even a small change in the input will result in a drastically different hash. Hashing is one-way and non-reversible, meaning you cannot retrieve the original input from the hash. It's commonly used to store passwords securely, verify data integrity, and generate digital signatures. 4. Hybrid encryption. Hybrid encryption combines the benefits of symmetric and asymmetric encryption. It starts by generating a random symmetric key for each data session, which is used to encrypt the actual data. Symmetric encryption. Then, the recipient's public key is used to encrypt the symmetric key. Asymmetric encryption, and send it along with the encrypted data. The recipient can use their private key to decrypt the symmetric key and then use that key to decrypt the data. Hybrid encryption offers the security advantages of asymmetric encryption without sacrificing the efficiency of symmetric encryption. These encryption methods play a vital role in securing IT systems and communications. They protect sensitive information from unauthorized access, ensure data confidentiality, preserve data integrity, and enable secure communication between parties. The strength of encryption lies in the complexity of the algorithms and the protection of the encryption keys, making it extremely difficult for adversaries to break the encryption and gain unauthorized access to the data. Merit. Explain why the different methods of encryption would be used. Encryption is the process of converting information or data into a secret code to secure it from unauthorized access or interception. Different methods of encryption are used depending on the specific needs and requirements of the situation. Here are some common encryption methods and the reasons for their usage. Symmetric encryption. Symmetric encryption uses a single secret key to both encrypt and decrypt data. This means that the same key is used for both the sender and the recipient. It is efficient and fast, making it suitable for encrypting large amounts of data. However, the challenge lies in securely distributing the secret key to all parties involved. Use cases. Data storage. When data needs to be encrypted for storage and decrypted for access within a trusted environment. Data transmission. Suitable for encrypted communication between two parties who already share the same secret key. 2. Asymmetric encryption. Public key encryption. Asymmetric encryption uses a pair of keys, a public key for encryption and a private key for decryption. The public key is freely distributed, while the private key is kept secret. Data encrypted with the public key can only be decrypted with the corresponding private key. Use ACEs, secure communication, ideal for secure communication between parties who have not previously shared any secret information. Distinction. Evaluate how effectively different encryption methods keep data safe. Encryption methods play a crucial role in securing data and protecting it from unauthorized access. The effectiveness of different encryption methods can be evaluated based on various factors. Here are some common encryption methods and their respective strengths and weaknesses. 1. Symmetric encryption. Strengths. Symmetric encryption is generally fast and efficient, making it suitable for encrypting large amounts of data. It is relatively simple to implement and requires less computational overhead. Weaknesses. The main challenge with symmetric encryption is securely sharing the encryption key between the communicating parties. If the key is compromised, an attacker can decrypt the data easily. 2. Asymmetric encryption. Public key encryption. Strengths. Asymmetric encryption offers a more secure way of sharing encryption keys. It uses two keys, a public key for encryption and a private key for decryption. The public key can be freely shared, but the private key remains secret. Weaknesses. Asymmetric encryption is computationally more intensive than symmetric encryption, which can slow down the encryption and decryption processes. It is not suitable for encrypting large volumes of data directly due to its computational overhead. Strengths. Hybrid encryption combines the best of both symmetric and asymmetric encryption. It uses symmetric encryption to encrypt the data, and then the symmetric key is encrypted with asymmetric encryption. This allows for secure key exchange and efficient data encryption. Weaknesses. Hybrid encryption can be more complex to implement and manage than individual encryption. Methods. Specification coverage. Introductory task. Have you ever heard of the term encryption? Yes, as an AI language model, I'm familiar with the term encryption. Encryption is a process of converting data or information into a code to prevent unauthorized access. The primary purpose of encryption is to protect sensitive information from being read or understood by unauthorized parties, while it is transmitted over networks or stored on devices. There are two main types of encryption: symmetric encryption and asymmetric encryption. 1. Symmetric encryption. In this method, the same key is used for both the encryption and decryption of data. The sender and receiver must share the secret key securely. Examples of symmetric encryption algorithms include AES Advanced Encryption Standard and DAT Data Encryption Standard. 2. Asymmetric encryption, also known as public key encryption. This method uses a pair of keys, a public key and a private key. The public key is used for encryption, and the private key is used for decryption. Only the recipient with the corresponding private key can decrypt the data encrypted with the public key. Examples of asymmetric encryption algorithms include RSA Rives-Shamir-Edelman and ECC elliptic curve cryptography. Encryption plays a crucial role in safeguarding sensitive information, ensuring secure communication over the internet, and protecting data privacy in various digital systems and applications. What transactions have you carried out online that used encryption? How do you know when encryption is being used? Would you still carry out online transactions without encryption? Pass. As an AI language model, I don't have the capability to perform online transactions or any actions on the internet. I am a text-based model designed to provide information and answer questions based on the data I was trained on up until September 2021. However, I can explain how encryption is typically used during online transactions and how you can recognize when encryption is being employed. 1. Encryption during online transactions. When you engage in online transactions, such as making purchases, banking, or sharing sensitive information, encryption is used to protect the data transmitted between your device and the server of the website or service you're interacting with. For example, when you enter your credit card details on a secure website, encryption ensures that your information is scrambled into an unreadable format during transmission, making it difficult for unauthorized parties to intercept and understand the data. 2. Recognizing encryption. You can identify the use of encryption on a website by checking for certain indicators. HTTPS. A secure website uses HTTPS. Hypertext Transfer Protocol Secure instead of HTTP in the website address. DS stands for secure, indicating that the connection is encrypted. Additionally, you might see a padlock symbol in the address bar, which also indicates that the site is using encryption. SSL, TLS certificates. Websites that use encryption typically have SSL Secure Sockets Layer or TLS Transport Layer security certificates. When you visit a secure website, you can click on the padlock symbol in the address bar to view details about the certificate and verify its authenticity. Deeper learning activities. Encryption. Describe what is meant by the term encryption. PASS. Encryption is a security technique used to protect sensitive information by converting it into an unreadable format, known as ciphertext, using an algorithm and a cryptographic key. The primary purpose of encryption is to ensure that unauthorized individuals or entities cannot understand the original data, even if they gain access to it. The process of encryption involves taking plaintext, which is the original, readable data, and applying a mathematical algorithm, commonly known as a cipher, to transform it into ciphertext. The encryption algorithm relies on a cryptographic key, which acts as a secret code, allowing authorized users to decrypt the ciphertext back into its original form. Encryption is widely used in various aspects of modern computing and communication to safeguard sensitive data, such as passwords, financial information, personal messages, and corporate data. It plays a crucial role in protecting data during transmission over the internet, known as data in transit, and while stored on devices or servers, known as data at rest. The strength of encryption lies in the complexity of the algorithm and the length and uniqueness of the cryptographic key. Modern encryption algorithms, such as Advanced Encryption Standard AES, are designed to be highly secure, making it computationally infeasible for unauthorized parties to decipher the encrypted data without the correct key. Research and describe what is meant by the following types of communications encryption pass and evaluate how effectively they keep secure data. Distinction. In the field of communications encryption, there are several types of encryption techniques used to secure data during transmission. Among these, three important ones are: 1. Public key encryption. Public key encryption, also known as asymmetric encryption, uses a pair of keys, a public key and a private key. The public key is known to everyone and is used for encrypting data, while the private key is kept secret and is used for decrypting the encrypted data. The encryption and decryption processes are mathematically related, making it computationally infeasible to deduce the private key from the public key. 2. Advanced Encryption Standard AES. AES is a symmetric encryption algorithm, meaning the same key is used for both encryption and decryption. It is widely used due to its efficiency and security. AES operates on fixed-sized blocks of data and has different key sizes: 128-bit, 192-bit, or 256-bit, that determine the strength of encryption. AES has been extensively studied and widely adopted in various applications, including secure communication protocols, financial transactions, and data storage. 3. Secure Sockets Layer. Transport Layer Security SSL, TLS. SSL and its successor TLS are cryptographic protocols that provide secure communication over a network, typically used to secure web traffic HTTPS. They work on top of the standard communication protocols like HTTP and provide encryption, authentication, and data integrity. SSL, TLS use a combination of asymmetric public key and symmetric encryption to secure data during transmission. When you visit a secure website, your browser and the server negotiate a secure connection using SSL, TLS, ensuring that data exchanged between you and the server is encrypted and protected from eavesdropping and tampering. Evaluation of effectiveness. 1. Public key encryption. Public key encryption is very effective in securing data during transmission, as long as the private key remains secret. It is computationally infeasible for an attacker to decrypt the data encrypted with the corresponding public key. However, public key encryption is computationally more expensive compared to symmetric encryption, making it less suitable for encrypting large volumes of data. This is why it's often used in combination with symmetric encryption, where the symmetric key is exchanged using public key encryption. 2. Advanced Encryption Standard AES. AES is considered highly secure when used with appropriate key sizes. Its security is based on the difficulty of performing brute force attacks, where an attacker tries all possible keys to decrypt the data with a sufficient key length, e.g., 128-bit or higher. The computational effort required to break AES encryption through brute force becomes practically infeasible with today's computing power. 3. Secure Sockets Layer. Transport Layer Security SSL, TLS. SSL, TLS has proven to be a robust and effective protocol for securing data during transmission over the internet. It offers a strong combination of public key and symmetric encryption, ensuring data confidentiality and integrity. However, the security of SSL, TLS can be compromised if not properly configured, or if there are vulnerabilities in the implementation or underlying cryptographic algorithms. Keeping SSL, TLS up to date and using the latest secure configurations is essential to maintain its effectiveness. In conclusion, all three types of encryption, public key encryption, AES, SSL, TLS, are effective at keeping data secure during communication when implemented correctly. Each has its strengths and weaknesses, and the choice of encryption depends on the specific use case and security requirements. It's essential to follow best practices, use appropriate key sizes, and keep the software and protocols updated to ensure the highest level of data security. Research and explain why the following uses of encryption would be used by organizations. Merit. Encryption is a critical tool used by organizations to secure their data and communications. It involves converting information into a code or cipher so that unauthorized individuals cannot access or understand the original data without the proper decryption key. Below are some common uses of encryption by organizations. 1. Data protection and privacy compliance. Organizations deal with vast amounts of sensitive and confidential data, including customer information, financial records, trade secrets, and intellectual property. Encryption helps protect this data from unauthorized access, ensuring compliance with data protection and privacy regulations, such as the General Data Protection Regulation (GDPR) in the European Union, or the Health Insurance Portability and Accountability Act (HIPAA) in the United States. 2. Secure communication. Encryption is employed to secure communication channels, both internally within the organization and externally with clients, partners, or suppliers. For example, when data is transmitted over the internet or other networks, it can be vulnerable to interception or eavesdropping. By encrypting the data during transmission, organizations can prevent unauthorized parties from intercepting and understanding the content. 3. E-commerce and online transactions. In e-commerce, encryption plays a vital role in securing online transactions. When customers enter sensitive information like credit card details, encryption ensures that this data remains confidential and cannot be accessed by hackers or cybercriminals during transmission or storage. 4. Protecting intellectual property. Companies often rely on encryption to protect their intellectual property, trade secrets, and proprietary information, whether it's software code, research data, or business strategies. Encryption can safeguard this valuable information from theft or unauthorized access. 5. Cloud data security. With the increasing adoption of cloud services, organizations need to ensure that their data stored in the cloud is adequately protected. Encryption is used to secure data at rest and in transit, providing an additional layer of protection against potential data breaches and unauthorized access. 6. Mobile device security. Encryption is commonly used in mobile devices to protect sensitive data stored on smartphones, tablets, or laptops. If a device is lost or stolen, encryption prevents unauthorized access to the data, reducing the risk of data exposure. 7. Secure file sharing. Organizations often need to share sensitive documents or files with authorized parties. Encryption ensures that only those with the appropriate decryption keys can access and read the shared content, preventing unauthorized recipients from viewing the data. 8. Secure messaging and email. Encryption is used to secure instant messaging, email communications, and other forms of electronic communication. This helps maintain the confidentiality of conversations and prevents interception by unauthorized individuals. Let's solve the chart to check your progress.
Thanks for watching. For more information, like, comment, and subscribe our channel.